Standard classification trees optimize unconditional impurity reduction, failing when a stratification factor Z acts as a confounder. Splitting on compound predictors X times Z is computationally prohibitive, and separate trees discard cross-group information. Simultaneous Latent Budget Trees, or SLBT, solves this by embedding a simultaneous latent budget model directly into the split criterion. At each node, SLBT approximates observed response budgets as a mixture of latent budgets. The split is governed by mixing parameters alpha that drive observations to children based on conditional probabilities per group, and latent budget parameters beta that update the response profile for each level of Z. This is a model-based split, not just heuristic impurity reduction. For ranking predictors, SLBT uses the partial predictability index tau, evaluating the proportional reduction in impurity of Y due to X conditional on Z. The split selection iterates to maximize predictability improvement, bounded by the global predictability improvement. Estimation is handled via a least squares procedure, framed as a simultaneous neural latent budget network. We model the data cube as a set of double-layer perceptrons with indicator inputs. The objective function minimizes the reconstruction error of the response matrices, transforming parameters via exponential mappings to enforce non-negativity and sum-to-one constraints without matrix inversion. SLBT supports 4 homogeneity constraints: unconstrained, homogeneous mixing, homogeneous budgets, or both. In an ALS case study with gender as Z, the constrained SLBTA model showed that while the tree structure is shared, the latent budgets diverge. Lift measures revealed bulbar impairment drives terminal stages in males, while upper limb decline is more predictive for females. Leaf classification ratios highlight minority class overrepresentation in terminal nodes. SLBT provides a rigorous, interpretable alternative for stratified classification, implemented in an open-source library with visual pruning.